So this is our function h of t, where h is the height of an object that we just threw up in the air. And then the initial velocity that we threw it with would be 30, and the initial height would be 7 in this case. So if we want to find the maximum height of this object, we first want to find the time at which it hits maximum. And whenever there's a maximum on the height of the object, the velocity is changing from positive to negative. Because if you think about it, when the object is going up, when it goes to the very top, it stops momentarily. But what we're going to want to do, if we want to find that time, is take the derivative, and h prime is the same as v of t, so that's going to come out to be negative 9.8 t plus 30. And so when v goes from positive to negative, it's going to go through 0. So if we were to substitute 0 in, which is what we're going to do, get something that looks a little like this. And then what you can do from there is just substitute for t. So t is going to look like negative 30 over negative 9.8, which is going to come out to be 3.06. So now if we want to find the actual height, then we just plug in 3.06 to wherever we have t in the height function. So there's going to be 3.06 squared right about there, just a regular 3.06 right about there, and then plug it in here just for show. That doesn't actually mean anything. But if you do put this in your calculator and do all the math, it will come out to be 52.9. And that's going to be the maximum height of this object. So now let's say we want to find the time when it hits the ground. So for that, when it hits the ground, the height obviously is going to be 0. So you could just plug in 0 for your height in your height function. Then you'll have something that looks like this. And then you got a really ugly looking quadratic here. And I'm sorry to tell you that the only thing that you're really going to be able to do with this is do the quadratic formula. So that's going to be negative b plus minus square root of b squared minus 4ac. Hopefully you remember that from whenever you took algebra 1 or whatever, all over 2a. And then keep in mind that the a is negative, so you're going to have something over a negative. But at any rate, when you do plug in your a, b, and c, what you're going to come out with is two values, and one of them is going to be negative, so you know that's just not right. And your positive value, which is when it's going to hit the ground, is 6.35. Then if we want to find the velocity at that time, when it's right about to hit the ground, you just plug in the time you just got, which is 6.35 for v. So v of 6.35 is going to be negative 9.8 times 6.35 plus 30. And when you plug that in your calculator, do all the math, you'll come out with negative 32.23. And that's how fast it's going when it hits right before it hits the ground. Because obviously once it hits the ground, then a whole lot of things come into play. But you'll see that it's both negative and very close to the initial velocity. And that's because it didn't change height very far. And the negative is because it's moving down. So it's losing meters in height in every second it goes by.